Hey guys, Mr. Ye here, and today I'm going to be covering section 1.5 from our textbook, which deals with solving inequalities. And the good news is, if you are comfortable with solving equations, then this section should be pretty familiar to you. It should go pretty well, so let's dive in. Okay, so solving inequalities. I have a few symbols here on the board. These are relational operators, so you should probably recognize them. The first one being less than, the less than symbol, followed by less than or equal to, greater than or equal to, and greater than. And so these dots underneath, I'm hoping you've seen this before, but in case you haven't, an open dot in mathematics typically means we do not include that value in our solution. So if I had a number line, for example, and we'll call this 0, and we'll call this 3, and I had an open dot on 3, and a closed dot on 0, and everything shaded in between, that would mean that all of our solutions are between 0 and 3, and that 0 is included in that solution set. 0 is a possibility, but 3 is not. So 3 is an exclusive bound. We do not include 3 in our solution if it has an open dot. Similarly, if we see something like, oh, x is greater than or equal to 0, like we have there, then we draw a closed dot on 0 to signify we are including that value in our solution set. So before today, you've solved lots of equations, we've seen them, and so something like 3x minus 8 equals 7. Pretty straightforward. If you followed the last lesson, we're just going to add 8 to both sides. So 3x equals 15, divide by 3 on both sides, and we get that x equals 5. That's how we solve equations generally, right? Now, inequalities from this section are not that different. I'm still going to try to get x alone. I'm going to add 8 to the other side. So we'll get 3x equals 15. And then I'm going to divide by 3 on both sides. Divide by 3, divide by 3, we get x equals 5. Except I did make a mistake here, and so I'm going to fix that right now. It wasn't equals, was it? That's the whole point of this lesson. It was an inequality. The good news is we started out with there being a greater than sign, and it's just going to stay that way. Greater than, 3x is greater than 15, which means x is greater than 5. So whole point of this lesson, inequalities, we are going to keep that inequality sign there, but it handles just like an equation for the most part. More on that later. How would I graph and represent on a number line x is greater than 5? Well, kind of like I showed you before, I have this number line already drawn out. I always like to mark 0, and that way we know where 0 is. It's kind of a common grounding point. So I'm going to write 5 here. I want to mark all the values that are greater than 5. And so I don't want to include 5 in my solution set. So there's that open dot. And then I'm going to shade in or highlight, because I have all these tools at my disposal. I'm going to highlight everything to the right of 5. So x is greater than 5. Any of those values will make this a true statement. Okay, so next one. Pretty simple one. 2x is less than or equal to 9. This is a one-step inequality because there's only one step to get x alone. I'm going to divide by 2. I'm going to divide by 2. X is less than or equal to 9/2. And so if I wanted to, again, put this graphically on a number line, I need to know where 9/2 is. 9/2, if you're not sure, you can always come to your calculator and say, what is 9 divided by 2? It says 4.5. So, okay, I need to go 1, 2, 3, 4.5. I'll call this 9/2. And I want to shade everything less than or equal to this value. So because it's less than or equal, we can put a closed dot because of the or equal. We want to include that value. And shade everything to the left. Now, one thing we typically want to do on these problems is it's a good idea to check it. I like to say on this problem, I'm going to check 2 points. One that should work according to my number line and one that should not work according to my number line. So quick way to check and this also goes into some calculator knowledge, I'm going to pick something that's shaded and just say, okay, if I plug it in, will I get something less than or equal to 9? So what if I picked 0? 0 is my favorite number to plug in. It's typically really easy. Is 2x, so 2 times 0, is that less than or equal to 9? And of course, this is a pretty simple problem. We know, yes, 2 times 0 is less than or equal to 9. So my value over here, I tested 0, and it worked the way I thought it would. It did satisfy the original inequality. What about something that should not work? Let's test one point on this number line that should not work according to our shading. So how about 5? Because we said 9 halves was 4.5. So I'm going to try plugging in 5. Is 2 times 5 less than or equal to 9? The answer is no, it's 10. And so it didn't work, but that's okay because that's actually what we wanted. We plugged in 5, which is not shaded, and it did not work. So our answer looks pretty good. We tried something that should work, and it did. We tried something that shouldn't work, and it didn't. So now I'm feeling really good about this answer, x less than or equal to 9 halves. Now, I did say there was one thing that's a little different when it comes to solving inequalities as compared to equations. And you might have heard this rule before, you might remember it. When you are solving an inequality, you do need to flip the sign if you multiply or divide by a negative number. Flip the sign meaning less thans become greater thans. Less than equals become greater than equals. So in this problem, negative 3x plus 1 less than 7, I'm going to start by subtracting 1 on both sides. We get negative 3x is less than 6. And for this first part, I'm going to pretend I forgot about this rule, okay? So I forget to flip the sign. I'm going to divide by negative 3. And we would say x is less than negative 2. Again, this is incorrect. I'm pretending I didn't realize that I needed to flip this sign. And I'm doing this for a reason. Because when it comes time to put this on a number line, and there's negative 2, and it's less than that, so I'm going to open dot it and then shade everything on this side. I could move on. I could move on and possibly get the problem wrong, but with what I just said, let's check two values. I'm going to pull out my calculator and I'm going to say, okay, what if I plugged in negative 3? Because that's somewhere shaded right now. It's to the left of negative 2. So if I said negative 3 and I plugged it into the original, so negative 3x, negative 3 times negative 3, plus 1, is that less than 7? And it says it's 10. And so this is where checking really comes in handy because you're like, wait a second, it's shaded, it should have worked, but 10 is not less than 7, it didn't work. And so that's a cue to go back, look through your work, and you're like, oh, I divided by a negative number. That means I do need to flip the sign, which means x should be greater than negative 2. And now let's check a couple things. I'll try negative 5. So negative 3 times negative 5, and then plus 1, is 16, which is not less than 7. And that's okay, because negative 5, we tried it. It's over here somewhere. It's not shaded. We didn't want it to work. What about something that should work? We could always go with my favorite 0. Negative 3 times 0, add 1, and we get 1, which is less than 7. So 0 worked. Feeling really good about this answer now. X greater than negative 2. So that's why checking, especially on inequalities, is a really, really important and good idea because it can save you little mistakes like that. As soon as you check it and you don't get what you expected, you're all set because the check will find it. You'll look back through your work. You'll realize I divided by that negative 3 and we move on. We correct our mistake. So one here with a fraction, making it a little bit trickier. 7 minus 1/8 x is greater than or equal to 4. So I'll start by subtracting 7 on both sides. Gets rid of it on the left. Negative 1/8 x is greater than or equal to negative 3. So negative 1/8 x, I need to get x alone. That means I need to divide by negative 1/8 Or I'll demonstrate this other way. I could multiply by something. I could just multiply by the denominator. I could multiply both sides by 8. Because then on the left, this 8 I'm multiplying by will cancel with the denominator. And we get negative 1x. I'm just going to write that negative x. It's that invisible 1. Is greater than or equal to negative 24. Awesome. We have one step left to get x by itself. It's almost by itself. It's not quite there. I need to divide by that negative 1. And of course, if I'm dividing by a negative, that's going to remind me to flip my sign. Greater than or equal became less than equal. X is less than or equal to 24. So that's what I'm thinking. I'm just going to say 24 is right about there. Less than or equal, so I can have a closed dot. And this is what I think the solution is. I think. So I'm going to show you another calculator trick. And this is one of my all-time favorite calculator tricks. It's the ability to store a value in a variable and use it later on. So watch what happens right now. I'm going to hit this X button. It's right next to the green alpha button on my calculator. And if I say X, enter, right now, 6 is saved in X. And what does that mean? Not much, other than X equals 6. What if I said, what is 2X? What is 2 times X? Well, it used that 6, it did 12. What if I did X minus 4? It'll use that 6 and say, what's 6 minus 4? 2. So how we are going to use this for our own purposes, let's save in X what we want to test. So I'll try testing 0. 0 is shaded, 0 should work. I'm going to say 0 store, which is this button right above the on button in the bottom left corner. It says STO with a little arrow. 0 store in the X variable. 0 store in X. And when I hit enter, it'll say 0. It says, got it, 0 is stored in there. So what I can do now is just enter the entire left-hand side of my inequality. 7 minus 1/8 X. And it'll use what I asked it to use. It'll use the 0 that I'm plugging in. It'll say, that's 7. Is 7 greater than or equal to 4? Yes, it is. That was a highlighter. So 0 worked, and it should have. How about something that should not work? Let's try 25, for example. 25 is not shaded. Let's see if it doesn't work. All I have to do now is go 25, store X. It says, got it. I'm going to use 25 whenever you type in X. And I'm going to say, what is 7 minus 1/8 X? This is 3.875. Is that greater than or equal to 4? No. So looking at that original inequality, it's not greater than or equal to 4. So it didn't work, which we didn't want it to. We didn't shade it, so we were hoping it didn't. This answer is looking better by the minute. So that's how you can use your calculator's store function to store values and plug them in without having to do the mental math with those fractions and such. So here's what I am going to ask you to do is try these two problems. Try working them out, try checking those answers, try graphing them on a number line. I'm going to pause the video. And so I recommend you do the same, pause it, work these two out, and then hit play. And when we come back, I'm going to have my work on the screen, have them worked out, and we'll see if our answers match, and hopefully they do. So pausing the video right now. All right, so hopefully you paused it, you had a chance to work these two problems, and now you are comparing your answers to mine. On the left-hand one, the negative m plus 7 less than or equal to 9, my final answer was m greater than or equal to negative 2. And you can see my number line below. So I'm going to test two things. One thing that should work, so I'm going to store 0 in X because it should work. I should mention, just because the calculator uses X and our problem uses M, that's not a problem. We can just pretend it's an x in our problem. So I'm going to say negative x plus 7, plus 7. And now that I have 0 stored in there, it'll plug in 0 for me. And is that less than or equal to 9? Yes. So 0 worked. Gotta change back to my pen. 0 worked. Something that shouldn't work, let's try negative 3. And I'm going to show you one more calculator trick today. I'm going to say negative 3 store in x. And then this is also a really useful trick to save some time. If I hit the blue second button in the top left corner, and then I hit the enter button in the bottom right corner, what does that do? It grabs the last thing I typed in, which I don't really want that right now. But I'm going to go second enter again, and it'll type the second to last thing I typed in, which is what I want to check. Negative x plus 7. Now I have a new x value. I want to see if this is a true statement. I'm kind of hoping it's not. I got 10. Is 10 less than or equal to 9 plugging into the original? No. So negative 3 did not work. This answer is looking good. On this second problem, the green one, so what I got here is the exact same process. I got j is less than or equal to 7/11. So something that should work, I'm going to type 0 store in x. 0 is shaded, it looks like it should work. And now I'm going to type out the left-hand side of my inequality, the original, is x plus 7 in parentheses divided by 6. So that's the left-hand side, plugging in 0. I get 1.16667-ish. Now I need to evaluate the right-hand side, 2j or 2x. That's 0. So is 1.17-ish, is that greater than or equal to 0? Is the left-hand side greater than or equal to the right-hand side? Absolutely. So 0 did work. So I can come over here and say, yep, 0 worked. Something that shouldn't work. 7/11 is a little bit less than 1. So 1 should not work. I'm going to say 1 store x. I'm going to say second enter to get that second to last thing. Second enter, that third to last thing. That's the left-hand side of my equation, x plus 7/6. So 1.3 repeating. Is that greater than or equal to the right-hand side? 2x. 1.3 is not greater than or equal to 2. So this did not work over here at 1, which it's not shaded, so I didn't want it to. Life is good. So inequalities hopefully is a topic you've seen before, you've studied before a little bit. That's all I'm going to talk about for today. Once again, if you need to, take the time to rewind this video, to watch an example, to listen to the explanation again, and maybe most importantly, to try these problems on your own to make sure that you can work them correctly. If you didn't work a problem correctly the first time, just go back, pause the video, write the problem down again, and see if you can ingrain how to work that problem in your mind. Because it's muscle memory. Math is all muscle memory, and if we practice it and we practice it correctly, then we'll have the confidence and the know-how to solve it correctly when we need to. So guys, that's all for today. If you have questions, please get in touch with me, let me know. Otherwise, I will see you next time. Bye.